Have you ever stopped to think about what happens when you stir a little salt into a glass of water? I mean, it seems so basic, right? But what you're actually doing is kicking off this amazing chemical process that's literally everywhere, from the soda you drink to the very air you're breathing. So today, we're going to pull back the curtain and demystify what's really going on in that glass. Seriously, think about it for a second. The salt just, poof, it disappears. It completely vanishes into the water. But you know it's still there because you can taste it. So what's the magic trick here? What's actually happening on a molecular level? What do we even call this?
Well, what you're doing is creating what scientists call a solution. It's a special kind of mixture that becomes perfectly uniform, or what's called homogeneous. And this isn't just some weird kitchen experiment. The science of solutions is behind fizzy drinks, the massive oceans, and yeah, even the air filling your lungs right now.
Okay, so what are the key players in this process? Well, turns out every solution has two main components, two main characters. And once you understand their relationship, you start to see this little chemical dance happening all over the place. First step, you've got the solute. In our little saltwater experiment, the salt is the solute. It's the thing that gets dissolved. And here's a super easy way to remember it. The solute is usually the ingredient you have less of. And the second player? That's the solvent. This is the one doing all the heavy lifting. It's the substance that actually does the dissolving. So in our glass, the water is the solvent. It's the one you have more of, and its job is to break down that solute. You know, here's a great way to think about it. Imagine a party. The solvent is the host. It kind of creates the whole environment, and there's more of it, right? The solute is the guest that shows up and mixes into the crowd. The host does the dissolving, the guest gets dissolved. It's a pretty perfect analogy for how these two work together. Okay, so we've got our solute and our solvent all mixed up. We've got our party going. But that brings up a new question, doesn't it? How do we describe the party? How do we measure exactly how much guest is mingling with the host? I mean, if you were making soup, this would be a really important question, right? Is it just a tiny pinch of salt? Or did you accidentally dump the whole shaker in? In science, we need a really precise way to answer that. How do we put a number on the saltiness? And the answer to that is a word called concentration. It's really just a measurement of how much solute is packed into the total solution. It's the scientific way of asking, how strong is this mixture? And it's a super straightforward idea. A little bit of solute gives you a low concentration. We'd call that a weak solution. As you start packing more and more solute in there, the concentration goes up and you get a strong solution. It's really that simple. More salt means a higher concentration. But, you know, saying something is strong or weak isn't very precise, is it? Science loves numbers. So how do we actually calculate the concentration? Well, it turns out there's a simple formula we can use. We're going to use one of the most common methods out there, called mass by mass percentage. I know, it sounds a little technical, but trust me, it's not. It's just a way of figuring out what percentage of the solution's total weight is actually just the solute. Let's just walk through it with our example. Imagine we have 100 grams of salt, that's our solute, and we dissolve it in 400 grams of water, that's our solvent. So what's the total mass of the whole solution? Easy, just add them together, 500 grams. Now for the formula. You just take the mass of the solute, divide it by the total mass of the solution, and then multiply by 100 to get a percentage. So let's plug in the numbers. 100 grams divided by 500 grams, that gives you 0.2. Multiply that by 100 and boom, 20%. The concentration of our saltwater solution is 20% by mass. See? You just did some real chemistry. It's not so bad. So far, we've been pretty focused on this one glass of salt water. But here's the really cool part. The reason this stuff is so important is that once you understand this basic concept, you'll start to see it absolutely everywhere. Just check out this list. The air you're breathing this very second, that's a solution, with oxygen as the solute dissolved in a nitrogen solvent. Your favorite soda? That's just carbon dioxide gas, the solute, dissolved in water. From the deep blue sea to a simple cup of sweet tea, solutions are the name of the game. This quote really nails it. A solution is a homogeneous mixture. Remember that word from earlier? It just means the mixture is perfectly uniform. You can't see the little bits of salt and the bits of water anymore. They've blended together into a single consistent thing. So here's the main takeaway, the crucial point. What we saw in that simple glass of water isn't just a party trick. It's a fundamental principle of chemistry. It's a simple dance between the guest that gets dissolved and the host that does the dissolving. And that dance is happening all around you all the time.
All right, so I'll leave you with a final question to chew on. Now that you know about solutes and solvents and this whole dance they do, what do you think is the single most common solution on planet Earth? Give it some thought. Thanks for joining me on this one.